what's the worst case scenario for genetically engineering microbes?
Well, I can give two or three examples of genetically engineering the microbes or the viruses. First is the pandemic. I'm not going to discuss the origins of COVID-19. We don't have to make our point. We can look at H5N1 avian flu. It's estimated to be up to 24 times more fatal than COVID-19. The fatality rate has been rated as high as 60% by the World Health Organization, 53%, 52%. Some put it more like 25%, but it is way more dangerous, more deadly than the COVID-19 virus. Now, in order to get this brand of avian flu, you have to be around these birds for a long time. It doesn't pass easily between humans. Some genetic engineers made an airborne version of it. Now, this is absolutely crazy to create an airborne version so it can pass through breath. They used ferrets. It could pass from one ferret to another that had no contact. Now, it never escaped the lab, but to even create it, knowing about the possibility of lab escapes, there have been over 1,000 lab accidents in secure labs. They found live smallpox in a cardboard box in a storage area in a lab when it was only supposed to be in 2 labs in the world forever, one in Siberia and one, I think, in Virginia. They have shipped accidentally live anthrax. They have caused spills. It is so unsecure in these secure labs to create these genetically engineered versions of potentially pandemic pathogens is crazy. So that's one scenario, massive death. Okay, you said worst case scenario. Here's another one. In our film, Don't Let the Gene Out of the Bottle, which you can watch at protectnaturenow.com, we introduce an experiment that was almost a cataclysm. Not just a catastrophe, a cataclysm. Well-meaning scientists. The scientists are not the enemies. They do what scientists do. They tinker. They try to use their toolkit to improve something. So these well-meaning scientists genetically engineered a type of bacteria called Klebsiella planticola. It's found in the root structure of every plant in all terrestrial systems that they've checked. I think it helps break down that cellulose. They engineered it so that it would turn plant matter as it's broken down into alcohol. And the idea was to distribute it to farmers who normally burn the crop residues on their field. Instead, they'd gather it and put it into large buckets or drums and add the bacteria. And then in a couple of weeks, they open the spigot and they'd have alcohol to run their tractors or to sell off farm. And the nutrient-rich sludge was to be spread on the fields as fertilizer. Now, this bacterium passed all of the regulatory requirements of the EPA in the early 90s, and they were going to do an experiment to see how far it would spread. They were going to release it outdoors, and it was scheduled for a particular date. 2 weeks before that date, a graduate student, Oregon State University, I believe, PhD student, who was doing research on the genetically engineered microbe, not because it was required, not because the developers asked it. He asked them to do research because he needed to do something for his PhD research. So he took that nutrient-rich sludge, mixed it with soil, put it in a tray, and planted wheat seeds compared to controls. Came into his lab. All of the wheat seeds on the nutrient-rich sludge were slime. They had all died. He first thought he had made a mistake. It turns out that the bacteria in the nutrient-rich sludge was still active, and it turned the roots and then the plants to alcohol, killing it. His advisor, Elaine Ingham, brought this information to the world, told the UN about it, because if it were to spread and displace its non-GMO counterpart, it would be destroying the root systems everywhere it went. And how far would it go? She was told by people at the EPA that they had conducted a secret experiment, which they disavow knowledge of to this day, where they actually released genetically engineered bacteria in a field in Louisiana. And a year later, that had found that it had traveled 11 miles, and then another growing season, then another growing season. Eventually, the EPA stopped testing, but some EPA employees continued to take samples and test for it. And eventually, they found it everywhere on the planet that they tested. So now imagine if the Klebsiella planticola transformed the natural version, which is found everywhere on Earth, to one that kills terrestrial plants. As you'll see in the film, Don't Let the Gene Out of the Bottle at protectnaturenow.com, Elaine Ingham said the natural consequence could be the end of terrestrial plants. This is a cataclysm. There's another version of genetically engineered bacteria, which we'll talk about. You can see it, which could have theoretically changed weather patterns, maybe permanently. And these are just 3 examples: H5N1, Klebsiella planticola, Pseudomonas syringae. These are just 3 examples that could have widespread, devastating consequences. So you ask the worst case scenario, I would say massive death and ecosystem collapse. We're talking existential threat. It should come of no surprise to people that GMOs present an existential threat, especially when you start broadcasting the technology and changing so many things all at once without even doing the simple safety studies. But even if they did the most in-depth safety studies they could possibly do, research shows that when you release a GMO, whether it's a microbe or a plant, it can change in subsequent generations. Traits that you've engineered can be switched off. Other problems you never anticipated can appear. It can transfer genetic material to other species. They have a gene drive, which is engineered to pass on to all future generations the trait that you're creating. So they want to wipe out rats on an island. They want to wipe out certain mosquitoes. What if that trait disappears, as it can, or transfers to another insect or animal, wiping them out, or maybe making a more virulent, more dangerous, more disease-prone, or more resistant mosquito accidentally? So you can pretty much make up any nightmare scenario that you want, and it could be plausible. So protecting against genetic engineering the microbiome is essential activity for this generation.